Okay, so here we go with solutions 2 review. So we're talking about this question right here. Talks about an unsaturated aqueous solution of ammonia at 90 degrees Celsius, 100 grams of water. So first thing you have to do is find table G. So this is table G over here. I'm going to shrink this down just a little bit so we can all see it. All right, so table G shows you the solubility of different substances at a variety of temperatures. So the one we're talking about right here is ammonia, NH3. And actually, you don't even need to know the name. NH3 is this one right here, okay? And it's always out of 100 grams of water, and it says at 90 degrees. So 90 degrees, 100 grams of water, you go over here, 90 degrees, 100 grams of water, crosses right there, all right? So it's that spot right there. So it says, according to the reference table G, how many grams of ammonia could this unsaturated solution contain? Well, the saturated solution is going to be right there at 10, and there's the answer. But an unsaturated solution, remember, an unsaturated solution is anything under the line. So therefore, the only one that's under the line is 5. So 5 grams is unsaturated. Anything less than 10 at 90 degrees and 100 grams of water is going to be an unsaturated solution. 10 would be a saturated solution. Anything above 10 would be a supersaturated solution. Second question, the solubility of any substance that is a solid in water increases as the temperature increases. So if we go back to table G here, we see this one's going up, that one's going up. They're all going up except for this one, and this one, and there's one other. There's 1, 2, 3. They're all going up except for those 3 that are going down, which are gases. Sulfur dioxide, ammonia gas, hydrogen chloride gas. Gases decrease solubility as the temperature goes up. Everything else, the solubility increases. So the solubility will increase as the temperature of the solution increases. Pressure will have no effect whatsoever because we're talking about a solid. Pressure only affects gases. So this one right here says the solubility data for 4 different salts in water at 60 degrees is shown below. The thing you want to do is you want to figure out, okay, what is 10 grams out of 50 grams? So do a little calculations real quick there. Doing some quick calculations. 10 out of 50 is 0.2. 20 out of 60 is 0.333 or a third. 30 out of 120 is a quarter, 0.25. And 40 out of 80 is 0.5. So its question says, which salt is most soluble? Well, it doesn't really matter what the temperature is because that's the temperature we're talking about. So we're looking for this one, 40 out of 80, because that one's most soluble. That has 0.5 grams. Next question, reference table F. Again, it's a difficult table to read. It says, according to this, which of these compounds is most soluble? And this question is different than the one you have on yours because I changed the answers, and I don't remember what the answers changed to because if you look at this one, it says lead chloride, silver chloride, lead chromate, lead 2 chromate, and lead carbonate. And it says which one is most soluble. If you look at this, you're like, wait a minute. Lead chloride, insoluble. Silver chloride, insoluble. Eddy carbonates, they're insoluble. So how does this one work? Well, it's because the chromates, they're all insoluble as well. This was based on the old table F. So I changed the answer for this one. I don't remember what the new question is, so I'll have to get back to you on that one. So sorry about that. Number 5 says, which ion, when combined with chloride, forms an insoluble substance? So down here on table F says, all right, all the halides, of which chlorine is a halide, all of those are soluble except when chlorine's with silver, lead 2, or mercury 1, dimercury. Iron chloride is going to be soluble. Magnesium chloride, there's the one that's the exception, lead 2 chloride. Lead 2 chloride is the one that's going to be insoluble, right there, lead 2 chloride. So therefore, that's the one that is insoluble. Number 6 is which compound is least soluble in 100 grams of water at 40 degrees Celsius. So basically, all you're going to do is find all of these things on this graph and see where they cross 40 degrees. It's 40-degree line right there. All right, so that 40 degree, and then you just go through and find out where sulfur dioxide, sodium chloride, these, and highlight those. And so when you do that, you'll see, oh, here's the lowest. And it says, which is the least soluble? The least soluble is going to be the one at the bottom. The most soluble will be the one at the top. Again, never pick the middle two. So there it is. Sulfur dioxide is the least soluble in 100 grams of water at 40 degrees Celsius. Oops, did I skip one? Nope. So number 7, it says, according to reference table G, how does the decrease in temperature from 40 degrees Celsius to affect the solubility of ammonia and potassium chloride? Well, first thing, excuse me, first thing you need to remember is that ammonia is a gas, potassium chloride is a solid. If you don't remember that, find the two. Here's ammonia right here. There's a gas. That's solubility is going down as the temperature increases. Potassium chloride, KCl, that's this one right here. This one's solubility is going up. So according to reference table G, as the temperature goes from 40 to 20, so temperature is going down. So if temperature is going down, solubility of the gas will go up, and the solid will go down. NH3 increases, KCl decreases as the temperature decreases. Number 8 says the solubility of a salt in a given volume of water depends primarily on, well, solubility, as you can tell from table G, is primarily based upon the temperature of the solution, temperature of the water. You can see the salts, these here, they're all solubility. The big thing that they're dependent upon is the temperature. Number 9, a solute is added to water and a portion of the solute remains undissolved. So this one's a tough one because people think, okay, you put something into water and it dissolves. Well, here it's saying some of it doesn't dissolve. So you stir and stir and stir and stir and stir, and still some doesn't dissolve, and it's sitting on the bottom. Well, what does that tell you? Well, that tells you that that solution, that water, that liquid can't hold any more. It's holding as much as it can. And what do we call that? Well, we call that a saturated solution. This right here says when an equilibrium between the dissolved and undissolved solute is reached, this solution. But that's just a fancy way of saying, hey, I've stirred as much as I can and nothing else will dissolve. That means it's saturated. That's simply the fancy way of saying I've gotten as much to dissolve as possible. I can't get any more. That means it's saturated. And this one here, let's again shrink this down for you. A solution contains 60 grams of sodium, and that 3 should be up here. I don't know why it jumped down there. But anyway, dissolved in 50 grams of water. Well, remember, this is out of 100 grams of water. This is 100 grams of water. The question is asking you out of 50 grams of water. So first thing you have to do is say, all right, where's 50 degrees? So 50 degrees is the first thing I need to find and where that is. So highlight. So there's 50 degrees. And we're talking about NaNO3. So find NaNO3. So highlight that on the paper. Let's go with this. So NaNO3 is right here. So right there, it's going to cross right about there. So what is that? So we can get right exactly where it goes up. So we're looking at about 115. So you're going to do a little ratio here. Now, no, that's not right. This should be 100, not 120. So let me get that. Let me back up. Sorry about that. So in 100 grams of water, we can get 115. So right here it says in 100 grams of water, I can get 115 grams of NaNO3 completely dissolved right there, 115. The question is asking, well, how much can you get in 50 grams of water? Well, it's just a simple ratio. 115 in the 100, say it was X in the 50, figure out what that number is. Is it going to be 60? Well, 120 would be 60 in 50, right? So that would be up here. That would be up here. Well, that would be what? What would we call that? Well, that would be a supersaturated solution. If it's above that, that'd be a supersaturated solution. All right, I think that's the last question. And yep, it is. So if you guys have any questions, feel free to text me and through reminder, and I'll answer them. Thanks.